So, what exactly is a library in programming? Imagine you're building a car. You wouldn't forge your own engine bolts or invent a new type of tire. You'd use standardized, pre-manufactured parts. The C Standard Library is your collection of high-quality, pre-built parts for software. It's a set of functions and definitions that handle common tasks for you. Having established what a library is, let's look at the first major benefit: efficiency. The functions in the standard library, like sorting or mathematical calculations, have been written by C language experts. They are highly optimized for speed and minimal resource usage, often outperforming anything a typical programmer could write on a deadline. This lets you build faster programs faster. Beyond speed, the second benefit is reliability. Every function in the standard library has been used by millions of programmers and tested across countless scenarios for decades. This rigorous real-world testing means they are incredibly stable and bug-free. By using them, you inherit that stability and drastically reduce the number of potential bugs in your own application. The final core benefit is portability. The C Standard Library is, as the name implies, standardized. This means if you write C code on a Windows machine using standard functions, you can be confident it will compile and run correctly on Mac OS or Linux with little to no modification. It's the universal language that all C compilers agree on, ensuring your code is portable across different systems. Now that we know why the library is so crucial, how do we actually use these tools? The first step is telling the compiler which part of the library you need. We do this with header files and the #include directive. Think of a header file like stdio.h as a menu. By writing #include stdio.h at the top of your file, you're telling the compiler, "I'd like to order from the standard input-output menu." Including a header tells the compiler what functions are available, like a menu listing dishes. But it doesn't contain the actual recipe. That recipe, the compiled code for the function, lives in the pre-built library file. The linker, a tool that runs after the compiler, is responsible for connecting your call to printf with the actual printf code. This two-step process keeps your code file small and efficient. With the header included and the linker ready, you can call a function. Let's break down the anatomy of a classic example. Printf hello. First, you have the function's name, printf. This is followed by parentheses, which hold the data the function needs. Finally, a semicolon ends the statement in C. It's a direct command. Execute the printf function with this data. The data you provide inside the parentheses is called an argument. A function is like a machine, and arguments are the raw materials you feed it. The printf function's argument is the text you want to display. The sqrt function, which calculates a square root, needs a number as its argument. Providing the correct type and number of arguments is essential for the function to work correctly. While some functions just perform an action, many also give something back. This output is called a return value. It's the result of the function's work. For example, when you call string length code, which measures string length, it returns the number 4. You can capture this value in a variable to use later, like this: int length equals string length code. With the mechanics covered, let's begin our tour of the most essential headers, starting with the one you'll use in nearly every C program, stdio.h. This stands for Standard Input and Output, and it's your primary tool for communicating with the user. Its main job is to handle input from the keyboard and output to the screen. The star of stdio.h is printf. It prints formatted text to the console. But it's more than just printing static text. Using format specifiers like %d for integers, %f for floating point numbers, and %s for strings, you can seamlessly embed variable values into your output. This makes it incredibly powerful for displaying dynamic information. Communication is a two-way street. To get input from the user, std.h gives us scanf. It scans the keyboard input for values that match the format specifiers you provide. For example, scanf %d and age will wait for the user to type a number and press enter, then store that number in the age variable. However, for reading strings, a safer function called fetchgets is often preferred as it helps prevent common security issues. Beyond the console, stdio.h is also your gateway to working with files. Functions like fopen let you open or create a file on the disk. Once a file is open, you can use fprintf and fscanf, which work just like their console counterparts, to write to or read from the file. Finally, fclose closes the file, saving the changes. This is fundamental for any program that needs to save data. Next on our tour is stdl.h, the standard library header. This is a general-purpose toolkit filled with essential utilities for memory management, data conversion, and more. If a function doesn't neatly fit into categories like I/O or math, there's a good chance you'll find it here. It's the Swiss Army knife of the C standard library. A common task is converting strings to numbers. When a user types 25, your program reads it as a string of text, not the number 25. stdlib.h provides functions like atoi, ASCII to integer, and atof, ASCII to float, to perform this crucial conversion. This allows you to take user input as text and use it in mathematical calculations. Perhaps the most powerful feature of stdlib.h is dynamic memory allocation. Functions like malloc, memory allocate, allow you to request a block of memory of a specific size while your program is running. This is essential for creating flexible data structures, like arrays whose size you don't know until runtime. When you're done, you must return the memory using free to prevent memory leaks. Moving on, let's explore string.h, the indispensable toolkit for text manipulation. In C, a string is just an array of characters ending with a special null character. Directly manipulating these arrays can be tricky and error-prone. String.h provides a suite of safe and efficient functions to handle everything from copying and concatenating to comparing and searching strings. Two of the most common string operations are getting a string's length and making a copy of it. The strlen function takes a string and returns its length, excluding the final null character. For copying, strycpy copies one string into another. However, a safer alternative is strncpy, which also takes a size argument, helping you prevent dangerous buffer overflows, a major security risk in C. Next, let's look at comparing and combining strings. To see if two strings are identical, you can't use the double equal sign. Instead, you must use strc, which compares them alphabetically and tells you if one is less than, greater than, or equal to the other. To join two strings together, you use strcat, which appends a copy of one string to the end of another. For any program that needs to perform mathematical calculations, math.h is your go-to header. It provides a comprehensive set of functions for everything from basic arithmetic to advanced trigonometry. Need a square root? Use sqrt. Need to raise a number to a power? Use pow. It also includes functions like sine, cos, and log, turning complex math into simple, single-line function calls. Sometimes you need to inspect individual characters. For this, C provides a small but very useful header, ctype.h, the character type library. It's filled with functions that test characters. For example, isDigit checks if a character is a digit from 0 to 9. Isalpha checks if it's a letter. And isSpace checks for white space. It also includes functions like toUpper to convert a character to uppercase. Our final stop is time.h, which provides functions for working with dates and times. You can get the current system time,
calculate differences between two times, and format time and date information into human-readable strings. This is incredibly useful for logging events, measuring code performance, or simply displaying the current date in your application. Now, let's put it all together. Here's a program that asks for the user's year of birth, calculates their approximate age, and prints a message. Notice we include stdio.h for input-output and time.h to get the current year. We use fetchgets and ATO to safely get the user's input and printf to display the final calculated result. Multiple libraries working together seamlessly. As you use these powerful tools, it's vital to be aware of common pitfalls. The most frequent beginner mistake is simply forgetting to #include the necessary header file. If you use a function like sqrt without including math.h, the compiler won't know what sqrt is and will give you an error. Always double-check your includes. Another common pitfall involves printf and scanf. Using the wrong format specifier, like trying to print a string with %d, can lead to crashes or nonsensical output. Even more dangerous is the scanf function itself. If a user types text when you're expecting a number, it can leave your program in an unstable state. This is why safer alternatives like fgets followed by scanf or ATI are often recommended. Finally, the most critical pitfall in C programming is the buffer overflow. This happens when you try to copy a large string into a smaller buffer using an unsafe function like strcy. The extra data overwrites adjacent memory, which can crash your program or, even worse, create a security vulnerability that attackers can exploit to run malicious code. Always use size-aware functions like strncy. With so many functions available, how do you remember them all? You don't. Professional programmers constantly refer to documentation. Websites like cppreference.com or the built-in man pages on Linux provide detailed information on every function, what header it's in, what arguments it takes, what it returns, and important usage notes. Learning to read documentation is a crucial skill. Let's quickly recap our journey. We learned what the standard library is and why its principles of efficiency, reliability, and portability are game changers. We explored the core mechanics of using it, from headers and linkers to function calls and return values. We then toured the essential libraries, stdio, stld, string, math, and more, and learned how to avoid critical pitfalls. You now have the foundational knowledge to effectively use the C standard library. By mastering these tools, you're no longer just writing code. You're engineering robust solutions. You are building on a foundation of expert-level code, which allows you to focus on your unique problems. This is your C superpower. Now go, practice, and build something amazing.